I'm going to try and explain to you bond formation when carbon is sp2 hybridized. So we're going to talk about carbon atom, and we're going to specifically talk about this molecule first. So you have this carbon atom and it is bonded to 3 atoms, which basically means that whenever carbon is bonded to 3 atoms, carbon is sp2 hybridized. So the 4 outer orbitals of carbon are going to look like this when it is bonding in this fashion, when it's bonding to 3 atoms. So one of the atoms that it's bonding to is oxygen. So oxygen has an electronic configuration of 1:2:2, 2px2, and 2py1 and 2pz1. So let's underline these outer orbitals. Oxygen needs 2 electrons, one in 2py and one in 2pz. And let's look at hydrogen. Hydrogen just has 1 electron, so it has an s orbital, and an s orbital needs 1 electron. So let's try and figure out how they're going to bond. So I have hydrogen over here. So there's going to be a hydrogen atom. On this side, hydrogen has a nucleus, it has a spherical orbital, and it has 1 electron in that spherical orbital. So it's going to attract one of the orbitals, sp2 hybridized orbitals, towards itself, and carbon is going to attract its electrons. So the electrons would get stuck somewhere in the middle. So the new bonding orbital is going to, the electron density would be found somewhere in this shaded region, somewhere in the middle between the 2 hydrogen nuclei and the carbon nuclei, which is over here. Similarly, there's another hydrogen atom bonding to carbon, so it would be bonded to this sp2 hybridized orbital over here. So this is the nucleus. It has 1 electron in this s orbital. Carbon is going to try and attract that electron and try to fill its sp2 orbital. Hydrogen would try to attract carbon's electron. They're both going to try and attract each other's electrons. The electron density would be maximum somewhere in the middle, because the electrons are being attracted by both atoms. And lastly, you have an oxygen atom at the other end. So oxygen, if you look carefully at oxygen, the electronic configuration of oxygen has a 2py and a 2pz orbital. So it has 2 orbitals which need an electron each. Now if you look at oxygen's 2 orbitals, one is 2py, and let's think of 2py as being on the axis next to this sp2 orbital. So there's going to be an end-to-end overlap. Both orbitals need an electron, so they're going to try and pull each other's electrons. So this carbon would try and pull oxygen's electrons, oxygen would try and pull carbon's electrons, and they're both going to try and pull each other's electrons. So the electrons are going to get stuck somewhere in the middle, and they're going to end up forming a sigma bond. The region of maximum electron density would be somewhere in this region over here. Now you're left with carbon has the 3 sp2 orbitals of carbon have now bonded, have formed 3 sigma bonds. Now if you look at these p orbitals, oxygen has a p orbital which is parallel to carbon's p orbital, and since the 2 orbitals are in parallel, they're going to end up forming a pi bond. The electron density of this particular oxygen atom, the p electron would be attracted by carbon, and oxygen would try and attract the other p orbital towards itself. So they're both going to try and attract each other's electrons. So the electrons would get stuck again somewhere in the middle. They're not able to occupy the region in between, because that's already occupied by electrons, so they're going to get repelled. So there's going to be an overlap above and below the axis. So there's going to be an overlap of orbitals above and below the axis, and they're going to end up forming a pi bond over here. Let's go over the bonding once again. This is the carbon nuclei. Carbon had 3 orbitals that were sp2 hybridized. So 3 of the electrons in the 3 orbitals got pulled in different directions by the atoms, one by hydrogen over here, one by another hydrogen over here, and one by the oxygen atom, which is over here. And you had a p orbital which was unchanged in sp2 hybridization. So carbon had an outer orbital which was completely unchanged. It was coming out of the axis, out of the page, and going into the page. So this p orbital ended up forming a pi bond with the p orbital from oxygen atom. So below I've drawn a neater version of this entire process. You have three. This is the carbon atom. It's bonded to two hydrogen atoms, and on one side it's forming a sigma bond with one of the oxygen atoms. So three orbitals of carbon are pulled in different directions. So that's a fan-shaped trigonal planar arrangement with all the angles between them. It's going to be 120 degrees. Whereas this blue orbital, this p orbital over here, ended up overlapping with the p orbital from the oxygen atom and ended up forming a pi bond above and below the axis. So this blue orbital is coming out of the page and it's going into the page. We're going to discuss the sp2 hybridization in ethene. If you look at the carbon, this is the molecule of ethene. If you look at the carbon is again bonded to just three atoms, one over here, and one on this side. And if you look at this carbon atom, it's also bonded to three atoms. So I have drawn two carbon atoms. This is carbon number 1 which is already sp2 hybridized because it's bonded to three atoms. So this is the other carbon atom, and the two carbon atoms are going to bond together. So in the middle they're going to attract each other's electrons. So one of the sp2 orbitals, these red orbitals over here, they are sp2 orbitals. So each carbon atom has three sp2 orbitals, and one of the orbital, the blue one, is the unchanged p orbital. So the sp2 orbitals are going to merge and bond with each other. So the region of highest electron density would be found somewhere in the middle. Similarly, the two outer orbitals of this carbon atom are going to bond with hydrogen. Hydrogen has an s orbital which is spherical. It has one electron in that, so it's going to attract, they're both going to attract each other's electrons. So the region of electron density would be maximum between the two nuclei. There's going to be another hydrogen atom bonded over here. It's going to attract sp2 electrons, and both of them are going to attract each other's electrons. So the region of highest electron density would be somewhere in the middle, and they're going to end up forming a sigma bond. The same would happen with the two sp2 orbitals pointing outwards over here. There's another hydrogen, let's label them, there's another hydrogen atom coming over here, and they're going to attract each other's electrons, and the electrons would get stuck somewhere in the middle. And then this final sp2 orbital of the second carbon atom is going to attract hydrogen's electrons, and the electrons would be stuck somewhere over here in the middle. So you have the four sigma bonds being formed. And the last thing, if you look at the sp2 orbitals, this carbon atom over here had three sp2 orbitals. Now all three of them have bonded with different atoms. This carbon atom also had three sp2 orbitals. All three of them have now bonded, and you're left with two p orbitals which were unchanged, which were not hybridized, and they're going to end up forming a sigma bond, so your pi bond, and they're going to overlap above and below the axis connecting the two nuclei. So the region of highest electron density would be somewhere in the middle. So this is going to be a pi bond, the formation of a pi bond. So you have this here is a sigma bond, this one over here is a sigma bond, this over here is also a sigma bond. So these are all sigma bonds, and you have one pi bond which is between the two carbon atoms. So the two carbon atoms end up forming one sigma bond which is end-to-end overlap, and one pi bond which is overlap of orbitals above and below the axis connecting the two nuclei.